Hello, in this video I'm going to solve question number 7 from this old national exam. Simplify the expressions as far as possible. So there are 3 expressions given. We are supposed to simplify them. Okay, so let us start. But before doing that, that would be a good idea if you pause the video at this point and give it a try yourself. Okay. So if you don't mind, let me solve the first problem here in front of it. So the common mistake is that people start simplifying right away, but this is not possible because we can only simplify common factors from the numerator and the denominator. And by factor, for example, when I say 6 is equal to 4 plus 2, I cannot say 4 and 2 are factors. 4 and 2 are called summands. But when I say 6 is equal to 3 times 2, here 3 and 2 are factors because they are being multiplied to produce 6. So here I wouldn't say that x to the power of 6 and x to the power of 3 are factors because they are summands. They are being subtracted here actually. So what you need to do, you need to factorize. So the denominator is as it is. There is nothing I can do. But in the numerator, you can see that I can factor an x cubed out. And what is left for me is just 5 minus x to the power of 3. It's always recommended to double check that you have done everything right. How? By multiplying this back to see if you are getting the same expression. X to the power of 3 multiplied by 5 really generates 5x cubed, so that's correct. Then I have minus x to power 3 times x to power 3. Becomes x to power 3 plus 3, which is x to power 6, and that is the same. So that's correct. But now, can I simplify this with that? Yes, because now you see that between this expression and that expression, I have a multiplication. So this means that x to the power of 3 now is a factor of the numerator, and it is a factor of the denominator, so it is a common factor and can be simplified. So now let me simplify this and that. When I simplify, 1 is left here, 1 is left there. So the answer becomes 5 minus x cubed divided by 1. So even though this answer is correct, but they have mentioned as far as possible, simplify as far as possible. So you shouldn't write this answer in the empty space. You just need to write answer 5 minus x cubed. And this calculation that you see here should be done in another paper. The only answer is required here. For the second one, so if you don't mind, let me do it here. The idea is the same, so I have to factorize the numerator and denominator and find the common factors from the numerator and denominator and cancel them out. Okay, so during the lesson I have told you that if you can factor something out from all the terms in the numerator, meaning the NpMa3c method, it has priority over any other methods of factorization. So the first thing that I will do in the numerator is to pull a 2 out in the numerator. So I pull a 2 out, x squared is left from the first, the second one will be simply 6x, and the last one will be 9, yes, and then divided. So the denominator is already in factorized form, but it is not fully factorized because x squared minus 9 is the conjugate pattern. So I factorize it one step further. So this becomes x minus 3, x plus 3. But so far, the only thing that I can simplify is this common factor of 2. So I simplify them. But if you look closer, you will see that this is also a pattern. That's a squaring pattern. So what can I do? I can write it as x plus 3 to the power of 2, and the denominator is still x minus 3, x plus 3. Yes? But now x plus 3 to power 2 means x plus 3 multiplied by x plus 3. So 1x plus 3 and 1x plus 3 are cancel. X plus 3 in the numerator is left, and x minus 3 in the denominator. So the answer becomes x plus 3, x minus 3. So the answer that you have to write is just simply x plus 3 over x minus 3. Okay, so the next one is of course a higher level question, but that is also very simple. So E is just a constant number, that's the Euler number. So in order to simplify this, you need to realize that in the numerator you can factor, of course you can factor e to power x out, and then what is left for you is 2 e to the power of minus x minus 1. And then the denominator you can copy and paste it, but nothing can be simplified. You see, nothing is the same. Okay, this motivates me to factor also a 2 out, even though it seems that this does not have a factor of 2, but it is manageable. How? So part C can be done in this way. I just copy and paste its denominator, e to the power of minus ax minus 0.5. The common thing is to pull this out, but it didn't work. So you have to pull this out. It's a little bit counterintuitive, but if you have experience and practice more, you can see that easily. So what I will do, I will factor 2 e to power x out. It is completely clear if I pull this out, then from the first one, this is the only one left, so it becomes e to power minus x. But I hope that you agree with me, the second term is just 0.5. As I told you, in order to understand that if your factorization is correct, you just multiply things back to see if I get the same expression. Let us check. If I multiply this to the first one, it becomes 2ex times e to power minus x, yes? And this is exactly the first expression. So that is correct. But if I multiply this by that one, first of all, there is a minus sign, there is a minus sign, so the signs are correct. But now 2e to the power of x multiplied by 0.5, these 2 and that 0.5 will be multiplied to 1, but 1 multiplied by e to power x is e to power x itself, and you see that here is also e to power x. So this factorization is correct. What was the benefit of doing this way of factorization, which is a little bit uncommon, is because now I can see that this expression is a factor of the numerator because this is a product, and this is exactly what you see in the denominator. So this one and that one can be simplified, yes? So this expression and that expression can be simplified. When I say simplified, 1 is left. And in total, what is the answer is just 2e to the power of x. And what you have to write here is 2e to the power of x. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.